Here's your vocab slide. I'm not going to take the time to read through them. You can pause the video. You can copy these all down into your notes. So, understanding science. Science is the investigation and exploration of natural events and the new information that results from those investigations. So we need to remember that science is of natural events. We're exploring, investigating natural events, not anything supernatural. People use reasoning, creativity, and skepticism in their daily lives to solve problems. So if you've ever asked why something happens and then investigated it, you're a scientist. That's how it works. Branches of science. There are many different branches of science, including biology, which is the study of living things. Bios means life, that's a prefix, and the suffix ology means study of. So anytime you see the words ology, that means study of. So down here when you see geology, we're still talking about the study of, in this case, Earth. So earth science is geology. Physical science, like chemistry and physics, we will be spending the first semester going over biology, and the second semester going over physical and earth sciences. Scientific inquiry. Scientists use a sequence of skills and methods when investigating a question. I'm sure you guys have done scientific method before. So, there's 5 steps. First, you have to ask a question. If you don't know what your problem is, you don't know how to solve it. So you need to ask your question. Observations are often the beginning of the process of science. Seeing something that sparks your interest can lead you to ask a question. The next step is to hypothesize and predict. A possible explanation about an observation that can be tested by scientific investigation is a hypothesis. So you're trying to explain what you think the cause of something is. A prediction is a statement of whether or what will happen next in a sequence of events. So in one situation, you're trying to explain what is causing something to happen. In a prediction, or in a hypothesis, you're trying to explain what's causing something to happen. In a prediction, you're trying to predict what's going to happen next in one set of instances. Testing is our next step. When you test a hypothesis, you're often testing your predictions. If your predictions are not confirmed, your hypothesis might need revision. You might need to go back and do it if your hypothesis is incorrect. Next, you need to analyze your data. Organize and analyze your data. That's pretty straightforward. You need to understand what your data means. If it doesn't make any sense or if it's unclear, then you need to redo your experiment. Drawing conclusions. Determine whether inferences can be made or conclusions drawn from the data. An inference is a logical explanation of an observation that is drawn from prior knowledge or experience. If the hypothesis is supported by the data, you can repeat the experiment to confirm results. If your hypothesis is not supported, you may need to modify it. Our last part here is communicating. It's not one of our 5 steps, but it's a very, very important process in the scientific method. The reason we use the metric system and things like that is so that we can communicate our data clearly. If we use a different system than everybody else is using, it's not very clear. And we want for everybody to be able to repeat our experiments and get the same results. Here's just a little graph of our scientific method. So we have ask a question, state your hypothesis, conduct your experiment, analyze results, make your conclusion. If your conclusion doesn't fit or your hypothesis is wrong, you can start back over. You can ask your question again, start your hypothesis again, conduct a different experiment, analyze the results, and make another conclusion. The results of scientific inquiry. We perform scientific inquiry to find answers to questions. It's that simple, whether they be really big questions or really small questions. The practical use of scientific knowledge, especially for industrial or commercial use, is technology. Scientific investigations answer the question who, what, when, where, and how. Scientific theory and scientific law. These two things are very different. A scientific theory is an explanation of observations or events based on knowledge gained from many observations and investigations. A scientific law describes a pattern or event in nature that is always true. So, a law is something that we've never seen go in the opposite direction. So, the law of gravity. We always see things fall down. That's never been a different case there. Critical thinking is comparing what you already know with the information you are given in order to decide whether you agree with it. You guys have done critical thinking before. You might be asked a difficult question, and we expect you as students to give thought to what the question is with new information, combining that with old information to figure out what your answer could be. To prevent bias, in an investigation, sampling, repetition, and blind studies can be helpful. Bias is when you have an assumed answer already. We don't want to assume any answers. We want to go in with an open mind and think that anything is possible in our experiments. So when we do that, we have a few different things that could help us do that. Sampling is going to be pulling different people out of the population to test on them or whatever you might be testing. Repetition means that we're going to be doing the experiment many times. And blind studies mean that the person giving the test and even the person having the test run on them might not know whether or not they're actually being tested. Questions about personal opinions, values, beliefs, and feelings cannot be answered scientifically. These are not natural things, right? You can't test whether someone's belief in one sports team is the right belief. Ethics are especially important when using living things during investigations. You can get into a lot of trouble if you're not acting ethically. These are a few different little organizers that if either any of them helps you, I would suggest that you draw them onto your notes after you've printed them off. So here we have, let's start over on this side with laws. So a law is a summary of many experimental results and observations. A theory is an explanation for many hypotheses and observations. So our laws are made up of facts. They're going to be found in the same area. Theories are going to be lumped in with hypotheses, and testable explanations. So down here describes what happens. An observation will describe what happens, but an observation is a small number of events. When it applies to all events and it describes what happens, it's a law. Explain why things happen, that's going to be a hypothesis. If it applies to all events, it's a theory. This is another chart that, again, if you think it's going to help you, feel free to copy it down. Scientific theory. A scientific theory is based on repeated observations and scientific investigations. If new information does not support the scientific theory, the theory will be modified or rejected. A scientific theory attempts to explain why something happens. A scientific theory usually is more complex than a scientific law and might contain many well-supported hypotheses. Scientific laws are observations of similar events that have been observed repeatedly. If many new observations do not follow the law is rejected. A scientific law states that something will happen. A scientific law usually is based on one well-supported hypothesis that states something will happen. So the example I keep going back to for a law is the law of gravity, right? That's an easy one. It says that gravity will always happen. We have many observations to prove that. And it's one well-supported hypothesis that that bodies have a pull of their own. Scientific theory, I don't know if you can think of any theories off the top of your head, but none of them are really proven. They're just an idea that explains a large set of hypotheses. Alright, so that will do it for this first slideshow.